So now we will discuss about addressing modes. So addressing mode is the way or the method how we access our data. So there are various methods to access our data. So all those methods we will discuss in addressing modes. So basically there are 5 types of addressing modes. One is immediate addressing mode. Second is register addressing mode. Third is direct addressing mode. Fourth is register indirect addressing mode. And fifth is index addressing mode. Indexed addressing mode. So these are the various methods how we access the data. So we will go one by one. So first we will discuss about immediate addressing mode. So we will discuss about these addressing modes by using a move instruction. So the opcode of move instruction. The opcode of move instruction is MOV. So the moment the binary code for move instruction enters inside the processor, and when it is decoded, then immediately processor will come to know that this is a move instruction. I have to move some data from one place to another place. Now this move instruction, this is opcode. Opcode means it specifies what this instruction is going to do, right? So what an instruction is going to do, that is called the opcode. So since this instruction is used for the movement of the data, so this MOV is a opcode. Now this instruction has 2 operands. First one is destination, and second is, after destination you have to put comma, then source. So what this instruction will do, it will move the data from source to destination. Right? It will move data from source to destination. So after the opcode, whatever we will write, that will always be the destination in case of move instruction, and after comma whatever we write, that will be the source of our data. So this part is our operand. So with the help of move instruction, we will discuss all the addressing modes. So now in case of immediate addressing mode, the data is the part of the instruction. Whatever data we want to move in destination is the part of instruction. For example, move AX, 1 to 9 BH. So here in the last it is customary to write the H in the last if this is a hexadecimal number. Okay. So now in this case, what is the meaning of this instruction? This is our destination. This is our source. So in case of immediate addressing mode, the number, the data is the part of the instruction. So here what is happening? This data 129B. This is a hexadecimal number which is equivalent to, in binary it is 16-bit number, right? So 1295. So 129 B. 1 means in binary 0001. 2 means 0010. 9 means 1001, and B. B means A is 10, B is 11. So 11 we write like this: 1 0 1 1. Right? So this is B. So this is a 8-bit number. This is a 8-bit number, 129B. Sorry, 16-bit number. 4-bit, 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 4-bit. So 16-bit. So this 16-bit number will be moved in AX register. So we know that AX register is formed by, AS is a 16-bit register, and this register is formed by two 8-bit registers like AL and AX. So lower 8-bit of AL and lower 8-bit of AX register is denoted by AL, and higher 8 bits of AX register is AH. So when this instruction is executed, then 129B will be stored in AX. So lower 8 bits. What are the lower 8 bits? These are the lower 8 bits. These are lower 8 bits. And these are higher 8 bits. So lower 8 bits will be stored in AL and higher 8 bits will be stored in AX. So in AL we have 1001. 1001 means 9 and 1011 means B. So in AL we have 9B, and in AH we have 0001 means 1, 0010 is 2, and in AH we have 1. So this is the meaning of this instruction. So if we want to move a 8-bit number, then also it is possible. Move AL, 34H. So now in this case, our destination is 8-bit, right? AL is a 8-bit register. So in 8-bit register, we can store only 8-bit number. So here we have to use our source should be 8-bit only. So here this 34 means 34H in hexadecimal, in binary you convert it. So 3 means 0, 0, 1, 1, and 4 means 0, 1, 0, 0. So these are the 8 bits, right? So this is 3 and 4. So this 8 bit will be moved in AL register. All the 8 bits in the AL register. You can use in the destination higher register also. For example, move AH, 34H. So now this 8-bit number 34H will be moved in AH register. So in this way, in the destination, we can use any general purpose register like AX, BX, CX, DX. We can use any of these registers, right? And we can use 8-bit register also. Means AL, BL, CL, DL, AH, BH, CH, DH. So any of these registers can be used as destination. We can also use in the destination our index registers. Index registers, for example, there are two index registers, source index and destination index, right? So we can write this instruction, move SI, 9AF3H. So we know that SI and DI, all these registers are a 16-bit register. So in this case, 9AF3, which is an 8-bit number, will be moved in SI register, right? So here one thing is, we cannot split the SI and DI in two 8-bit registers, just like general purpose register. So we cannot write this instruction, move SI, 34H. So now in this way, what will happen? This is a 8-bit number, and what we are doing, we are trying to move 8-bit number in 16-bit register. So this will give an error. So we cannot use this. We have to use the 16-bit number only. Now, destination can be general purpose register, index register, and they can be base pointers. Pointer registers like base pointer, stack pointer. They can also be used as a destination. For example, move SP, 13F0H. So here this 16-bit number 13F0H will be moved in stack pointer register, which is a 16-bit register. So in this way we can use all these registers. The only limitation is destination cannot be the segment register. Destination cannot be segment registers like CS, DS, ES, SS. These registers cannot be used as a destination. For example, move SS, 1234H. 1234H. So here what we are trying? We are trying to move a 16-bit number 1234H in stack segment register, right? So this is invalid. So this instruction is invalid. So we cannot use the destination, these segment registers. We cannot use in destination. And another limitation is destination cannot be IP, instruction pointer. Instruction pointer cannot be our destination. So these are the limitations, because you see here from pointer register we use only base pointer and stack pointer. Whereas IP, instruction pointer, is also a pointer register, but we cannot initialize the instruction pointer as well as segment register by using immediate addressing mode. Now, second addressing mode is register addressing mode. So again we will use same example of move instruction. So move instruction, we know there is destination and there is source. So here in register addressing mode, our source, which is our operand, it will be in some register. It will be in some register, and destination is also a register, right? For example, move AX, BX. So now here this AX register is a destination and BX is our source. So what this instruction is doing? Move the content of BX into AX. So move the content of BX into AX. So whatever is the value of Bx, that will be moved in Ax. Basically, you just remember this. This is not the basically move instruction. It is copy paste, right? So whatever is the content Bx, it will remain there in Bx. But only thing is that content will be copied in Ax, right? So always remember this. So students sometimes they have that confusion. Move means all the data of Bx will be moved to Ax. Then what will be in Bx? So data will be removed. No, the data will remain in Bx. Only thing is its content will be copied and pasted in Ax register. So this is a 16-bit register. We can move the content of 2 8-bit register also. BL, CL. So here the lower 8 bits of C register is moved in lower 8 bits of B register. Another example, move BH, CL. So lower 8 bits of C register is moved in higher 8 bits of B register. So it is possible that source and destination can be of different bits. Here we are having lower 8 bits. So lower 8 bits of one register can be moved in higher 8 bits of another register. Or another example, move BH, BL. So here 8-bit content of BL will be moved in BH. So you can use any combination. Now here one limitation. Source and destination both cannot be segment register. Source and destination cannot be segment register. Both cannot be segment register. For example, move SS, ES. So here what we are trying to do, the 16-bit value of extra segment register, we are moving it to stack segment register. So here our destination is stack segment register and source is extra segment register. So source and destination both are segment registers. That's why this instruction is invalid instruction. So this instruction is invalid. We cannot use this instruction. Source and destination cannot be segment register. Whereas one register can be out of two, source and destination, one can be segment register. Right? One can be segment register. For example, move DS, AX. So here our source data is in AX. So this data will be copied in DS register, which is our data segment register. So destination is segment register. Right? So this instruction is valid instruction because our destination and source both are not segment registers. So one register is general purpose register, second is segment register. So any this format can be used. Move ES, BX So here 8-bit content of BX register, we are trying to move in extra segment. So this is a valid instruction. So you must remember that you should not use that instruction in which you are using both source and destination same segment, right? So suppose in our memory, suppose this is our memory RAM. In the RAM, let us assume we want to make this particular area as our data segment. Right? This particular area we want to make as a data segment. And suppose this is our 64 KB. Now, if this area we want to make it as a data segment, then we have to initialize our data segment register, because data segment register is used to point the first location of our data segment, right? So this is our data segment. Suppose this is the first location of data segment. So this will be pointed by our data segment register, right? So let us assume that our data segment register is having a value, suppose 1000H, right? It is having a value 1000H. So how we will initialize our data segment? Because we cannot use this, we cannot use immediate addressing mode. If you remember, then I told you move DS, 1000H. This is invalid, because we cannot initialize the segment register with immediate value, right? Destination cannot be a segment register in case of immediate addressing mode. So then how we will load 1000 in DS? For this we have to use two steps, right? In first step, what I will do, move in some general purpose register like AX, I will store this value 1000, which I want to load in DS register. So now with this instruction, what will happen? Value of AX will become 1000H. After this, I will use register addressing mode. Move DS, AX. Now what will happen? Whatever is the value of AX, that will be copied in DS. So in AX, we already stored 1000H. So after the execution of second instruction, the value of DS will become 1000H. So in this way, we initialize the segment register. Okay, so if our DS register is having value 1000H, right? Then what is the physical address? Physical address of first location of data segment. Right? So what is the physical address of this location? First location. So this is our first location. What is the physical address? So for this, if the data segment is 1000H, then to calculate the physical address, the simple method is add one hexadecimal 0 at the right side. Right? Add one hexadecimal 0 to the right side. So 1000 is already there. Add another 0 and H. So this is the physical address. Right? So this address is 1000H. So basically what happened? If DS is 1000H, then our processor, right? In our processor there is bus interface unit, right? So that bus interface unit, what it will do? It will shift this number. So basically in binary, this is a 16-bit number. This is a 16-bit number, right? Our physical address is a 20-bit. So what BIU will do? It will shift this number to left side. It will shift this number to left side by 4 bits, right? It will shift this 1000 to left side by 4 bits. It is equivalent to putting 10 at this place, right? When we will shift 1000h to left side by 4 bit, so 4 binary zeros will be added here. So 4 binary zeros is equivalent to 10 of hexadecimal. That's why simple way is put 10. This is our physical address, and physical address is always 20 bit. So this is a 20 bit number, right? Because see, 1, 2, 3, 4, 5. There is 5 hexadecimal numbers. One hexadecimal number is equivalent to 4 binary numbers, binary bits. So 5 into 4, 20. In this way, this is 20 bit is the physical address of this particular segment. So or suppose there is one question, initialize data segment to 2000h, extra segment to 3000h, and stack segment to 4000h. Right? These are the 3 things required. So to perform these operations, what we will do? Move AX, 2000h. Whatever value we want to load in DS register, first we will load in AX. Then we will move the value of AX in DS, AX. Right? So this is done. Now we have to initialize ES. So here move. Again now we can use AX register, because already the value of AX has been used for the initialization of DS. Now in AX I will load 3000h. And after this, move ES, AX. So with this instruction, ES is also initialized by 3000. Now we have to initialize stack segment by 4000h. So move. Now you can use here any register. Suppose I am using BX. That is also possible. BX, 4000h. And after this, move SS, BX. So this instruction will initialize this. Right? So only limitation is we cannot initialize the port segment. Right? Here we cannot write this instruction. Move AX, 6000h, and after this move CS, AX. Right? So this is not possible. That initialization is not possible. So this is about the register addressing mode. So in next lecture we will discuss about the direct addressing mode and register indirect addressing.